All right, here we go. 8.3, estimating a population mean. So we talked about proportions already. So now we're doing 8.3, which is estimating a population mean. So it says draw an SRS of size n from a population of an unknown mean and known standard deviation. So underline that for me, please. This marker's dead. Let's try the other one. Go. So underline known standard deviation and normal condition is met. Okay? So when we're doing means, normally we do not use z for our critical value. Okay? That's something you got to know. We don't normally use z. This is a rare case. Okay? And it's also when we're trying to find the number, find n. Okay? So here's your basic formula. X bar, which is your sample mean, plus or minus the critical value times the standard deviation divided by the square root of the sample size. You can arrange to have both high confidence and a small margin of error by taking enough observations. Your margin of error, don't forget. Ready? This whole thing is the margin of error. Everything after the plus or minus is your margin of error. This is what's called standard error. Okay? That's just the standard deviation part. So we're going to talk more about that as we move through. Okay? So choosing the sample size. So we're choosing a sample size. All right? We're going to do this problem together. It says, how much homework? Administrators at your school want to estimate how much time students spend on homework on average. Not very much. During a typical week, they want to estimate you at the 90% confidence level with a margin of error of at most 30 minutes. A pilot study indicated that the standard deviation of time spent on homework per week is about 154 minutes. So they're giving you the standard deviation. Okay, they're giving that to you. So we want to estimate how much time students spend on their homework. Okay, so I think I need more to this. I think I need like another sentence. Let me just see what it says in the book. Yeah. So let me add this. You guys can add this right underneath it, okay? How many students need to be surveyed? Need to be surveyed. I need to add this to my notes at some point. I say it every year, then I never do. To estimate the mean number. To estimate the mean number of minutes spent on homework. Of minutes spent on homework with 90% confidence and a margin of error and a margin of error of at most 30 minutes. Okay? So there's our problem. So what I need to do is, we're talking about our margin of error. So that's the part after Okay, here it is, determine the sample size for desired margin of error. That's what we're doing here. So we have our formula, which is going to be z times the standard deviation divided by n, less than or equal to whatever that margin of error that they give us. Okay? So let's look. Critical z, what do they want? They want a 90% confidence interval. So for a 90% CI, I need to figure out what I'm going to use for the critical z. So I go over here, and I hit second distor, go to inverse norm. Now if it's 90%, that means there's 10% split between the two tails. I hit 0.05 or 0.95, and I get 1.645. So that is going to be 1.645 times the standard deviation that they gave me. Standard deviation they gave me was 154 minutes. Divided by the square root of n, we don't know. At most 30 minutes. Okay? This is what we got. Do the math. Let's do the math together. Right? So we've got this 1.645. 1.645 times 154. I get 253.33 divided by the square root of n. I'm just going to say equals for now. 30. We cross multiply. 30 root n equals 253.33. So I take 253.33 and I divide by 30, and it gives me root n equals 8.44. I've got to square both of those, and I get 71.3. So I would probably make that a 72. So how many do I have to do? 72. That survey has to have at least 72 students. To make sure we did that math correctly, let's go back and check that. So we had our 253.33, right? 1.645 times 154. 1.645 times 154 was the 253.33. Cross multiply. 30 times root n equals there. There we go. That's good. We're good. All right, so I'm going to pause the video for 1 second.